Okay, let me give you an example. In the next video, I will give you some practice. So here, solve this. But this time around, it's sine of 3x. Remember with our circle, our normal sine of x, means you would have done one period would be 360. But now that we've got sine of 3x, now that we've got sine of 3x here, it means that we would have done 1, 2, 3 revolutions in the time that it takes for the normal sine of x to make one revolution. So what that means is normally sine of x would one revolution would be 360 here. Now because of this 3 here, we've got 3 revolutions inside here. So here is one revolution, okay? Here is another revolution, and here is another one here. Because of this 3 here, we're doing 3 cycles in the time it takes for the normal sine of x to do one cycle. Okay, so later on, what that means is later on, once you find out this point here, you can't simply add 360, because once you've got this solution here, if you add 360, it will give you this point. This will be another solution. Add another 360, and then this will be another solution. You see, you're omitting this solution here, and then you're omitting this solution here. Okay, and then here you're also missing out this solution. You're also missing out this solution. So once you've got your first solution here, you can't simply add 360. You have to add well, if from here to here is 360, we'll cut it into 3 equal pieces. Okay, so basically it's going to be 360 divided by 3, which is 120. So once you've got your solution here, you have to add 120, add 120, add 120, add 120, and then later on you've got to develop a way of finding out this point here, and then you can add 120, and then you can add 120. You can't add 360. You can't add 360. You can't add 360 because you're missing out. Well, yeah, you just got to develop your own way of doing it. Okay, so let's find out our first solution. The first step is to find out the first solution here. So looking at this here, imagine this is being stuck in a bubble here. So you've got sine bubble equals 0.6. So now inverse sine to both sides. So bubble here equals inverse sine 0.6. Okay, so now jump to your calculator. So bubble here equals, jump to your calculator, punch in 0.6, and then inverse sine equals this. Let's round off to 36.9. 36.9. So now bubble equals this. Don't forget, bubble is 3. There's 3x inside that bubble here. So you can put 3x into here, or you can just say 3x equals 36.9. So to find out x, you would divide both sides by 3. So x equals this number here, 36.9 divided by 3 equals this, equals 12. Let's round off to 12.3. 12.3. Okay, so our first solution here is 12.3. This point here is 12.3, and then remember we can't add 360. Okay, we have to add we have to add 360 over 3, which is 120. Remember that the period is 120. So we got to so hang on. So we can write x equals 120. Sorry, x equals 12.3 plus 120n. Okay, because yeah, once we've got this here, we can add multiples of 120 120. That will, oops, that will give us, add 120 will give you this, add another 120, add another 120, it will give us this, or you can take away 120, take away 120. So this is our first set of solutions, okay? And then we also need to find out this point here. And again, you would need to develop your own way of doing, your own way of finding out this solution here. So 360 is this, it's one cycle. Divided by 3, that would give us this bit here. Okay, so let me just zoom into this bit here. Hang on. So let me just zoom into this. Hang on. So this is the same graph here. So our 360 from here to here is 360. If we get 360 divided by 3, that would give us this bit here. This here is one period, because look, one cycle here. This is one cycle. Okay, so get 360 divided by 3. That would give us this length here. But the thing is, so this length here is hang on. This length here is 120. If we cut this 120 into 2, or divide 120 into 2, it will give us this bit here. You see, this is nice and neat here because we've got this point here, so we can simply find out. Well, don't forget, from here to here, hang on, from here to here is 120. Get 120 divided by 2. That would give us from here to here. Okay, so don't forget this. This is 12.3. So this length here is 12.3. Yeah, hang on. This length here is 12.3. So if and from here to here is well, earlier one period is one. Hang on, let me just tidy this up. Sorry, one period here is 120. Okay, so if we from here to here is 60. So let's say from here to here is 60, and from here to here is 12.3. Okay, so here if we get 60, don't forget, hang on, 60 is like this. So at the moment we've got this here. At the moment we've got this box here. If we get 60 and take away this length here, that will give us this point. So really it's 60 take away 12.3. Okay, so hang on. So let me put this into memory. Memory store. Okay, clear. So it will be 60 take away our memory here equals this. You see, this point here is 47. This point here is 47.7. Okay, yeah. So this point here is 47.7. This point here is 12.3. Okay, so going back to here, this point here is 12.3. This point here is 47.7. So what we can do is to write this. X equals 47.7 plus the period. Remember, the period is 120, not 60. Okay. So here, yeah. So this is our second set of solutions. So overall it would be this. Hang on. Overall, our solution would be this. We have to write it as x equals, the first part will be 120. Sorry, the first part is 12.3 plus 120n, and now the second set of solutions, and 47.7 plus 120n for all. Remember, for all n belonging to the set of integer numbers. Okay, the set of integers. So this here is our final is the final way of writing all the solutions. Okay.